Now, if you ever been into industry for any length of time, you'll notice the total absence of these old high-speed steel end mills. Just about entirely. They're absent. So are these. This is an old grooving tool. These are absent as well. Partially because of the fact that they're slow. But what they make up for as far as with their slowness, you get some really crazy versatility. So you can grind just about any form taper or part you like. This is a little boring bar. And you can get these boring bars incredibly small. As long as your setup's rigid, you don't have too much stick out. You can get in some pretty tight spots without much issue. But again, they're slow. The alternative to a boring bar, say about this size, is probably, right about at your Swiss tooling margin. It's right about there. Just because they're so small that a Swiss lathe is pretty much all you're going to get that uses this type of tool. I think I made this to bore out a 22 for a chamber. It's a nice little project. But then your step up from your high-speed steel are these brazed carbide tools. And all it is a little bit of carbide that's been soldered on with probably silver solder to a piece of high carbon steel. And the issue with these is they're brittle. This one's got a ding at the end, and I don't have a wheel to fix it. And running carbide on any other wheel that's not designed for it just eats it up. So it's not much of an option there. Also, it chatters a bunch, so I'm afraid I'm going to break more of it. But, they're a nice alternative. If you've got the RPM and the horsepowers to take carbide nicely. This is one of my favorite tools. You can actually hog with this little guy. 100 thousandths on that on my little Clausing. And I think the feed's just like 2 thou per revolution. It's real slow, but it can blew up a chip real quick. You can also, the issue with these are, once you blew up a chip, you can blue the end of this, so you can pull the carbon out of the steel, and that's an issue. Once you start pulling the carbon out of the steel, you make the steel softer. You can get to the point where you're annealing the steel, so it doesn't have its hardness from the factory. So that's one of the issues. One of the other things you got to worry about is you often have to use lubricant. I don't think I've ever seen an application with high-speed steel you do not need lubricant. Especially with aluminum, but aluminum gums up everything. So as we're heading down here, we got this insert. This is aluminum insert. It's a pretty nice little tool. It's great for my machine. It's not one of those big tool holders. It's just a 1/4-inch tool holder. Positive rake, of course. I can't take anything negative. The machine doesn't have the power. Again, same thing here. Just a different insert style. I think this is a CMMG. Don't quote me on that. I don't have the paper in front of me. But the issue with these types of boring bars is the rigidity is almost null void. You can see I rubbed up against some aluminum. That was a bad thing. But this one's got through-hole coolant, which is nice when you've got the coolant, or you got a little oiler you can just stick up to the rear of this guy and just put the coolant right where it needs to be inside of a bore. But the issue with this one is because they removed the material, the rigidity on this guy is nothing. I mean, I could take heavier cuts with this piece of high-speed steel, and that's kind of the opposite is what you'd expect with this, is what I'm getting at. So, and then we got these really old, giant, well, I wouldn't say giant, I've seen bigger, I've used bigger, but I think this is 1.25 end mill. And you can see someone came in there, You can see multiple faces. Someone came in here and actually sharpened this one by hand, and it was used as a countersink, so you already drilled it out the hole, so you don't have to worry about this guy right here, which is just an empty pocket, because it's not a center cutting mill. And then you just plunge cut this guy in after that, and you'd have a quick and dirty countersink. But there's another thing you can do with this, and there's only one thing holding me back from doing it, and that's time. Well, I'll make it two things: time and this little cut out right there, where it's a radius right there at the edge. What I'm going to try to do, and this is a little crazy, I'm going to try to cut that at a 45-degree angle, probably about only 1/8 of an inch, and use this as a kind of a face mill. Give it a shot. It'd be kind of a cool little experiment. I've never seen it done before. So, and then this guy is just for real rigid profile milling. So, I just got this one in today. So. But it's a nice heavy piece of high-speed steel. And again, with these, you get it down, you send them out for a rerun, you get it back, you use it again. With this little bit of carbide, it chips or breaks, which is what it will do probably before it dulls, because carbide just, once it starts dulling, the forces aren't, your feeds will stay the same, but it doesn't have the same capacity. So it just wears, and it will either break here at one of the edges, or part of it will chip, and then as a part on a single flute will chip, it will embed itself into the material, and then as it goes around, it will just take out, and you'll see lines on parts where the end mills have just started to die, essentially. So, but they last long, especially if they have a coating. So that's, an upside. But you can also get a coating for high-speed steel. This is, I believe it's a titanium nitride. I think this is a nickel-based coating. But if you ever hear someone say tin coating, it's not actually tin. It's titanium nitrate. And that's what this is. This insert also has titanium nitrate on it. You can see that. So, but, I don't know. I titled this video, Why Buy High-Speed Steel? Reason being, it's so freaking cheap and versatile. Like, who cares? Like this little guy over here, he's well burnt out. Who cares? Grind a new phase. Grind that down. You've got a solid piece of high-speed steel you can still use. It's slow, but you can still use it. There's nothing wrong with it. Again, you can use the other side, and this is $8 a piece. I think some of the inserts I buy are $8 a piece. So that little bit of, I think in this case it's carbide. I don't think it's cement. That little bit of carbide can, in some cases, cost more than this. Now, they do make bigger inserts, but those are more expensive. And since I don't even have the horsepower for really using these properly, where the chip breaker works, it's not worth my money. But when these work, they're awesome. I've yet to find one that breaks the chip at the low horsepower I've got. But I'm still looking. I'll let you know when I find one. Yep. So I think that about wraps it up. Thanks for watching. See you all next time.